Welcome everybody in this webinar about the Fox crypto DataDiode. We will talk about DataDiode, what it is, how you can use it, and also explain why it's so frustrating for hackers that the DataDiode exists, and also why it gives a CISO a peace of mind. We will go into details during this presentation. Let me see. We will first talk a bit about market trends that we've seen in the past year, and then about the challenges that most customers or organizations are facing. Then we go into detail about the Fox DataDiode, what it is and how it works. And then finally, because doing a demo about a DataDiode is pretty boring, because you will see one file moving through the diode to the other side, and that's it. So instead of that, we will talk about client use cases. So what type of customers are using a diode and how are they using it? And what kind of problem is the diode solving for those customers? I think that's very practical information that could be useful. So first about the market trends that we see in 2024, but also the years before and also this year, basically. So if we start at the top corner on the left, ransomware. It's a thing that's going on for many years, but it's getting more and more serious. It's software that enters the network and can encrypt all data, and then the hackers want a ransom, mostly in the form of Bitcoin, and then they might release your data again, and you get your data back. It's a big problem. Then another one is supply chain breaches. So where hackers or malware enters the network through third parties. For instance, a hack of the retail chain Target in the US a while ago, where they had an air conditioning system connected to the network, so they could do remote maintenance and software updates in the air conditioning. And then hackers got into that system, and through that system got access to the point of sale checkouts of all retail stores of Target, costing them tons of money. This is one that's very actual today, attacks on critical infrastructure. There's a couple of blackouts that we've seen in the energy networks in a couple of European countries recently. Some people say, well, it's a software thingy. Others say, well, they were testing new solutions. But there's also a survey actually published this week, where in the Netherlands, some investigators found out that in parts of the solar energy systems that all the private people in the Netherlands are using on the roof of their house, there's something like a kill switch. And that kill switch can be remotely managed by China. So if shit hits the fan, then China could turn on the kill switch and basically create a blackout in the energy system. And by doing that, the whole energy or grid in the Netherlands might get a lot of damage, and the issues coming from that. Theft of the sensitive data is happening a lot, where hackers grab databases from an organization, they publish a little bit of the data, and then contact that organization asking for money. If you don't pay, they will publish the complete database. And the bad thing about this is that a lot of these hacks and attacks are being executed and done by state aggressors. So other countries, China, North Korea, Russia, and they have plenty of money to fund this. There's thousands of people working for these kind of organizations. For them, it's a daily job. They go to the office at 8:30 in the morning until 5:30 in the afternoon, and that's what they do. But they do it like 24/7. And there's many people working on that. So, and they only have to be right one time, and they have access to a network. And we and our customers and the organizations, we have to be right all the time and make sure we keep them out. And the DataDiode can be one of the solutions there. So what are the high-level challenges that we see in the market? The first one, we have two scenarios, basically. The first one is how to protect secrets. So if you look at this picture, there's the local area network where everybody is working in an organization. It's typically connected to the internet, so you can have access to the internet, email, file exchange with third parties, etc. And then in a lot of our customers' organizations, like governments, semi-governments, local authorities, police, defense, those kind of organizations, they also have secure environments. It's mostly, they call it like red networks, where people are working with very sensitive data. But they want to receive data into the secure network to start working with it and combining all the data in order to come up with information. Well, you don't want to connect this network to the public network that's connected to the internet. But you do want to bring data into the secure environment. In that case, you can apply a data diode. The data diode will sit in between. It will create a connection between the black and the red network, but data can only flow in one direction, from black to red, so they can receive the information. It's impossible, 100% guaranteed, the data from the secure network will flow from red to black. The data diode is blocking that. So it's really a one-way communication that's possible when using a data diode. Typical customers for this kind of scenario is central governments, police, intelligence, defense, but also more and more high-level commercial organizations, public transport, chip manufacturers, companies or pharmaceuticals, so companies with a lot of intellectual property, for instance, or knowledge about chip designs that you don't want to get in the hands of North Korea, for instance. The second scenario that we see is the way you can apply a data diode is to protect critical assets and operations. So on the left side, you see a network. We call it the OT network, the operational technology. It can be a plant, a CCTV system, where on the right side, you have the corporate network, where people are working that want to analyze data, and that network is connected to the internet, so they can do email and all that stuff. Now, you do want to have information about the plant, about the camera streams, to store it at a central location, perhaps databases that you want to replicate to the corporate network in order to analyze what's going on in the plant. In that situation, a data diode should be applied because you're connecting OT to an IT environment. With the data diode, you can grab all that information from the OT environment and transport it to the corporate network. And there you can work with that information. But it's impossible for a hacker that might have accessed this network or that's coming from the internet. It's impossible for the hacker to go the other way through the diode and enter the OT plant, because that's what you don't want. The data diode is blocking that. Typical customers in this scenario are oil and gas companies, water plants, power companies, power grids, transport for London. We will talk about that later on in the presentation. Nuclear plants. So all kinds of organizations that are running critical activities that could really hurt the country if something happens with that network. So if you look at cross-domain communication, what doesn't work? Well, if you have a black network and a secure red network, you want to bring information from the black to the red network. In defense, and that's basically where the whole data diode started, it's designed and developed by defense like 30 years ago. People work from the black to the red network. So it's really air-gapped. There's no connection between black and red. So if you want to bring information from black to red, somebody with a USB stick or a CD or CD-ROM will take the information, walk to the red network and implement it there. That's great. There's no online attacks possible because there's no connection between both networks. And so information from red can never leak. The disadvantage is it's very labor intensive. Somebody has to walk from black to red all the time. It's a person, so it's prone to human error. People can lose a USB drive, for instance, and the information is out there on the street. And of course, it's very slow. So a solution to solve this is to connect both networks, black and red, and put a firewall in between. So that way you can send the data over a 1 or 10 gig connection, for instance, to the red network. That's great. The firewall will protect you. The advantage is, well, you have a direct connection. It's very fast. It's flexible because you can open certain ports or protocols in the firewall to pass the data through to the red network. That's all very nice, and it's a big improvement compared to the previous scenario. But it's a firewall, so it's prone to misconfiguration. A lot of times there's different departments in an organization working with the firewall, and they need to open certain ports for certain activities, for a certain campaign. They do that, and then afterwards the ports are not closed or not in the right way, or there's multiple firewalls from multiple brands, and you get errors by doing that. So that you get holes in the firewall. You need to update the firewall frequently because there's new firmware with bug fixes available. So that's taking time and money. But basically, the firewall, it's a great tool and everybody should use it, especially on the edges of the network, but it's hackable. And we always say a firewall is software, and software can contain backdoors. Software can have bugs. Software is hackable. So how to overcome that? Ta-da, there it is, the Fox DataDiode. You can connect both networks, black and red, have direct connection between the two, and the data diode is making sure that data can only flow in one direction. No data can flow back to the black network. It's 100% guaranteed. So it's automated and fast because you install the diode and it's set and forget. It's sitting there, it's doing its job. Certified at the highest levels. That's why it's used by most governments and NATO organizations, for instance. And it's unhackable. It's pure hardware. There's no processor firmware in the diode. So there's no way to have backdoors or bugs or other things, or to access the diode, basically. It doesn't even have an IP address, so you don't see it. And it's low TCO. It's a one-time purchase, one-time installation, and it's there doing its thing, creating a one-way connection between black and red. But how does it work practically? Well, here in the middle, you see the hardware data diode from Fox. On the right side, you see the red network based on the fiber connection. Same on the left side, you see the black network connected through fiber. Information from black goes through the light, through the fiber, through the diode, to the red network, where it's received, and people can start working with that information. If somebody, by accident or deliberately, wants to send information from red to black, it's impossible. There's no light receiver in the diode on the red network. So it's by physics impossible, 100% guaranteed, that data can flow the other direction. That's why it's 100% sure that the data diode in this way always provides a one-way data flow. So the Fox DataDiode, we have two flavors. It's a 1 and a 10 gig connection. It's used by governments and in industry and in critical infrastructure. And we can tell you it's 100% secure, and that's why governments and police and intelligence is using it. But fortunately, there's external third-party organizations like Common Criteria that have frameworks that you have to adhere to get a certification. And the highest level with Common Criteria is EAL 7+, and that's what we have with the Fox DataDiode. That means that the diode, from the design, development, production, storage, shipping to the customer, that whole process from beginning to the end is documented and secure. So it's really secure by design from A to Z. It's also certified to transport NATO cosmic top secret information over the data diode. So that's why it's used by a lot of organizations. It's Tempest, so especially interesting for defense organizations. So even if somebody could get access to the to the premises or the data center. They could not get information out of the diode by using a sniffer, for instance, because it's tempest. There's no radiation where you can get information. It's ruggedized, so it can be used in a data center, but it's also used in vehicles, in the army, for instance. That's all possible. The solution, like I said, the diode is pure hardware. And around that, we offer software and consultancy to implement it in your specific situation. Because implementing a data diode, it's a very simple tool. It's bringing a very high level of security, but it's also breaking things because it's one-way communication, and a lot of two-way or three-way protocols, they can't deal with that. That's what we solve with our software. Things like this, the handshake in the TCP protocol, it won't work because there's no data coming back. How do you ensure data integrity? How do you know that the data that arrived in the red network is what was sent from the black network, that it's okay? How do you manage the flow control? Those are things that we solve by introducing proxy servers. So in the middle, you see the data diode, and to the data diode, you connect two proxy servers. One on the black network, that's with a fiber connection. The upstream proxy is connected to the upstream network, the black network. There's no configuration you have to do in the black network because this is two-way communication based on TCP/IP. Same on the red side. If a proxy connected to the downstream network, TCP/IP connection, nothing to change in the red network. And between the proxies and the data diode is what we call the data diode magic. That's making sure that TCP and FTP and those kind of protocols can be sent over the diode, even though it's two-way communication that's required by those protocols. So on the proxy servers, both on the black and the red network, we run the Fox software. There's two flavors. The data diode core, it's a software running on a proxy, and in our case, we offer Dell servers, but it can be an x86 machine. It can also be from HP or some other brand. And with that software, we support TCP, UDP, file transfers to be sent over the diode, but also email and other things. We have two flavors. One is running on the Linux OS, and one is running on Windows. With this core software, you get a lot of flexibility to implement all kinds of things on top of the proxy server, to enable FTP, to enable SMTP, and things like that. If people want a sophisticated solution, but with a UI where a lot of things are already pre-configured, we offer the Fox Appliance. It's a package that includes a Linux OS, the Fox core software, and also a user interface with a number of services like SMTP, FTP, things like that are already pre-configured in the system. So you can just configure it with your IP addresses and things like that, and you're up and running. Of course, you get less flexibility with the appliance because things are pre-configured in the UI. Yeah, the data sheet, I will not go through this in detail. Main message is EAL 7+, highest level of certification for the data diode from Fox. I think that's important. And another one, you're breaking a lot of things with regards to TCP, but a lot of protocols are possible when you introduce the proxy servers with the Fox software. FTP, NTP, SMTP, well, I will not go through the whole list, but also Modbus, OPC, PI, so things, protocols that you use in the industrial arena. Splunk, we see a lot where organizations want to bring a lot of log information into the red network to start analyzing that. We have a replicator to use there, but also databases based on MS SQL or Oracle. Well, there's a lot of protocols possible with the diode. Some are possible with the software as is. Others we can implement by using consultancy and tailor-make the solution in your network. Well, a couple of slides ago, you saw the Fox DataDiode with the two proxy servers from Dell in this case. Well, if you put it into a rack in the data center, it's like 3 shelves. It's a 3U solution, 2 servers and 1 data diode. For some customers, the rack space is an issue or the cost is an issue. So especially in industry where you need multiple diodes in most cases. So we introduced a 1U diode. We call it the Endian 1G because it's the speed of the diode is 1G maximum. But this is an integrated solution in a 1U shelf. So here in the middle, you see the Fox DataDiode. And then there's proxy servers on both sides. So this is all three solutions in one box, which is saving 2U rack space in the data center. First slide, I mentioned that Fox these days is part of the CR Group. CR Group is a Swedish company with a bunch of high assurance companies. Fox is one of them, focusing on government, defense, and critical infrastructure. One of our sister companies in CR Group is Toomas. I just want to mention this one slide because Toomas, they are also focusing on EU secret, NATO, and really high assurance solutions by offering VPN or firewall, software encryption, secure smartphones is a big part of their business. They have a secure client, a hardened laptop that's completely locked. A secure video conference, basically a secure Teams environment. And they even have deployed a secure cloud. So there's a bunch of additional solutions that we can now start offering also to our customers, also with Hermitage and Telia going forward, next to the DataDiode that we're talking about today. Just something I wanted to mention, keep it in mind, and we can also always dive into more details later on if there's interest. I will hand over to my colleague Marck van Haren, our senior pre-sales architect, who will explain about these client use cases.
Yes, good morning. As René mentioned, a lot of our customers try to protect their secrets and their critical infrastructure, and they hate hackers, and they also don't like it when their name is mentioned because that can attract hackers. Over the years, we were running the DataDiode for more than 25 years, but over the years we have collected all the information from our customers, and we even found some customers willing to share their use case, and I will go through it. So the first one who was willing to discuss this and say, you can publicly mention that we are using your DataDiodes, is the London Underground. They're part of Transport for London. And they already realized in early stages that they had to protect themselves. Because you can imagine what happens in London if the underground is not working anymore. So they looked at their solution and they decided that their signaling network, the rail signaling network in this case, needs to be protected. And they divided their signaling network into 40 compartments, 40. Each compartment has a DataDiode. So all the signaling information can go out to the central control room, but no one can get in. As René has shown in one of the pictures, it is really protected by the DataDiodes. So this provides them with a good overview of the entire network, where the trains are, what speed, where they're heading, whether it's still on time. But it is impossible, physically impossible, for the hackers to get in. They guarantee the integrity of the rail system. And yeah, from a technical perspective, we worked with our UK partner, Nexor. They implemented everything, and that was not that hard. The hardest part was getting all the paperwork done, the CESG compliance. That was more to prove that it complies with the rules as Transport for London is using it. But this is a perfect use case which shows the added value of a DataDiode. And does this frustrate a hacker? Yes. They really can't get into the signaling network from outside. So this is a perfect protection in this case. And René mentioned it already. Yeah, you can imagine that nuclear power plants, you do not want hackers inside. So in this case, it is also to frustrate the hackers. And the International Atomic Agency in Vienna, they demand that nuclear power plants are protected by DataDiodes. And what you do in such a situation, you segregate the OT network from the IT network. So all the information from monitoring perspective, temperature, valves, how often does a valve open, when is maintenance required for a valve or for a system, that all goes out to the IT environment. There you can combine it with the ERP solution and you can run your plant. And that's, again, also done via a Datadiode. So a Datadiode is a pretty simple device, but it really protects your environment. And that frustrates the hackers. Transelectrica is a Romanian company in the power grid. And yeah, they face a lot of attacks real time. And they also came to the conclusion, we do not want downtime. So our SCADA network, which is used to operate the electricity network, the power grid, needs to be protected. And they want information, log information out of the OT space into the IT space. And via that approach, they can protect their environment. Also simply via a data network, or a Datadiode, sorry. And Navy, first time when I saw this one and I spoke with the customers, I asked them, why do you need a Datadiode on a ship? Because you're at sea, there is no one near you. They said, well, you would be surprised. Once we enter port, there are so many hack attempts, we need to protect ourselves. So the data on the ship must be protected from intrusions from the outside. So on a ship, on a large Navy ship, you find dozens of Datadiodes, which separates all the critical networks inside the ship, the high security domain, from the outside. No one can get in, but they can send information out, like mission information, what they accomplished, what needs to be shared. That can go out, but from the outside, no one can get in. And these are examples where we were allowed to make it a little bit more visible, how it is being used by whom. But the following cases are really anonymous. I think 95% of our customers are using a Datadiode to transfer files across. So I have my black network, I have certain information, I send it across to the red network. There the data is enhanced, becomes more valuable, especially for hackers, but it is physically impossible that data flows back. And that can be a Samba share, that can be an NFS share, it can be on a proxy share, it can be on an external server where the share is. The Datadiode will pick up the information, send across, and make it available either here on the proxy or on other servers. Again, via this approach, you can share information and hackers will not get access to it. You can guarantee 100% that the confidentiality of all the information here remains. And yeah, sharing files via file share, everybody's using it these days, but in the early days, we had FTP and secure copy and SFTP. And that still works, even with a Datadiode in between. And the fact that the Datadiode is unidirectional. But what you do, instead of setting up an FTP session to the FTP server, you set it up to the proxy. There the file is received, sent across to the other side, and from here it's distributed either via FTP or SFTP, or it's placed on a share somewhere. The trick is that the clients, they talk to the proxy. They think this is the final destination. In reality, it ends up here. So the proxies are very important in a Datadiode solution, because for the outside systems, everything remains the same, i.e. TCP/IP continues to work. And the same applies to UDP and TCP streams. You send it to the proxy. The Datadiode solution makes sure it gets on the other end in the right format and without any errors, and then it's delivered to the destination. You can go very far with Datadiodes in creating solutions. We have our Datadiode for more than 25 years, and it evolved. We're now at version 3, and we'll release soon version 4. But yeah, we have developers working in our office, and they work for the Dutch Ministry of Defense. They create cryptographical solutions as well. And these people are working in isolated solutions, divided by a data diet. But if you're a programmer, you might need to look something up. And then you go to internet. And then you need to write down what the solution is and go back into the specialized room, which is shielded with thick steel walls, and you can continue programming. But these programmers were so fed up with that. They said, no, I need a kind of copy and paste solution. So on the data diet, there's a clipboard defined. And there's a little piece of program running on the client here. What they can do, they can copy paste the solution onto the clipboard, which runs on the proxy. That is transferred over, and when they walk back into the secure room, they can log on and get that information out of it. And that's copy paste over a data diet. HTTPS, widely used, REST APIs. Yeah, without a data diet, life would be simple because I get my answer back and everything works. But even if you send an HTTPS 200 request back, it will not go back. So what we did, we created an HTTPS replicator. The clients send the HTTP request to here, they get the OK back. This one sends it across, and here it's executed to the destination. And the same applies to REST APIs. So for the existing systems, nothing changes. What we see more and more these days is that customers say, okay, I've got a data diet, I'm happy with that. A hacker cannot get into the red network. But what if a hacker sends ransomware or malicious software to the other side? Maybe a country, they define something special to frustrate something in the red network. So customers are now using more and more scanners. Before you send it over the data diet, it's scanned, and it can be scanned for viruses. It can be scanned for content in Office documents or PDFs, but you start controlling what you let through. And customers, especially military customers, are doing that on the low side, the black network, but also on the high side, because there are two different administrator organizations on each side. And via that approach, you control more what's getting in. I'll skip this one. Oh. And the first component is the file foundation. So the file foundation runs on the proxy server, and you can do a simple fingerprinting. So within milliseconds, you know what type of file is this. Is this an archive? Is it encrypted? And then you can have policies. What am I doing with an encrypted file? Well, I don't know what's inside. So I place it in a quarantine, or I delete it. But I can also do the same with text files. I scan through the file, look for certain words, or XML. I only allow this schema to get through. If it's different, I place it in quarantine. And everything is configured via a simple web GUI. But you can go further. You can also do deep content inspections on Office documents and PDFs. You can say, for example, well, this is a Word document which contains macros. I will convert all the text into pictures and send it across. Or I will deconstruct, remove macros, and reconstruct and send it across. But you can also do content checking. You can say, hey, this piece of text, I see a white font on a white background. It's not visible to human, but the computer will see it. And will say, is this allowed to pass through? Yes or no? So via that approach, you can go very far. And of course, you can also scan for viruses and malware. Out of the box, it comes with Sophos, but there are many options to integrate it with. And of course, if you do input scanning, you get customers who say, yeah, but I need to send something out of the red network. So you need to do a kind of solution which scans for certain characteristics, but you always want a person to be involved. And for that, we have the workflow. And how does it work? user places a file in a share, file is picked up by the system, and based on the characteristics of the file, Active Directory is queried. And Active Directory comes back with a list of people who should approve the transfer of the file. And we one person, that can be multiple people. These people will receive an email. And then they have to make a decision based on all the information they see on the screen. Is it fit to release or not? If you have 10 people checking that and one says no, it will not be released. And if they say it's okay, then the file is released. What people don't realize is that you can also replicate databases. That is in industry, but that's also mainly used in government. So I have on the Black network a dynamic database, and it's used, it's updated, but you want a copy of the database to the other side. So we have replicators for that. For example, we have a Microsoft SQL replicator. And what does it do? First time, it takes the entire database, send it across, and load it in here. But then it checks, for example, once every 15 minutes. And then the sequential updates are sent across. If something goes wrong, which is theoretically possible, you can resend a certain update, because otherwise this database would be out of sync and useless. So that's all built in. We call it data loss prevention. And for Microsoft, we created a replicator. For Oracle, you have a solution more or less from Oracle themselves called Golden Gate. And for Postgres, MySQL, MariaDB, and so on, we have scripts which can do this. But the thing to realize is you can replicate databases over a data diet. AMQP, which is a queuing solution. And what you get, you have your, in this case, based on RabbitMQ, then you can have thousands of queues, and systems, usually they post messages on a queue. And then someone consumes the message and takes further action. Well, on Black that will work, but how do you do that on Red? We created an AMQP replicator. That means the replicator subscribes to the queues as well. It receives all the messages, sends it across, and delivers it to the queuing server here, so that all the clients can consume the messages. Of course, if someone posts a message on a queue here, it will not be shown here because the Datadiodes will prevent data to flow back to the Black network. Splunk. Splunk is widely used across the globe. It's now owned by Cisco, but yeah, you can imagine if a company or an organization is using Splunk, it collects all the log information from all IT systems within that environment. So if a hacker would get access to a Splunk server, yeah, it's a jackpot. You have all the information centralized in one place. So a lot of our customers say, ooh, we want to protect our Splunk indexing and searching tier. How can we do that? And we sat down with Splunk, and they advised us to work with heavy forwarders based on the Splunk HTTP event collector, the hack replicator. So we wrote our replicator, it connects to the heavy forwarder. It can be one, it can be multiple ones, sends it across, and then it arrives here. If a hacker will try to get there, the Datadiodes will block it because there is no return path. And that's the way to frustrate the hacker. The industry, they start to realize we need to protect ourselves. And some very critical infrastructure, they already realized that in the early days. Think of all the oil companies in the Middle East. They were already way ahead of everybody here in Europe in the past. And for protecting yourself, well, the OT environment has specific protocols, and OPC is one of them. It's widely used, and yeah, they do not always have the latest technology as well, So it will be widely used as well going forward. And for that, we created an OPC replicator. So the entire OPC and SCADA infrastructure sends the information to the OPC server. Our replicator connects with the server, send it across, and make it available here in the corporate network. And OPC is one flavor. You also have Modbus, also a long existing protocol widely used in the industry. And for that, we also have a replicator. So you can get all the information out of your OT network and transport it over the Datadiode to the IT network, where you can use the information. One thing which I find very positive is an airport package handling system. And why? Well, we were phoned by a Dutch company. They create airport package handling systems, and they said, help. We sold to Singapore a airport packet handling system. We want to go live. And the government said, no, you don't have a Datadiodes. And what is a Datadiodes? They asked. So we explained, we worked with them, and within a day, they had the solution working. But what I find encouraging is that Singapore is already way ahead of Europe again with protecting their critical infrastructure. By law, they can force organizations to use Datadiodes. And that's what we should do in Europe as well, because they realize if a hacker gets in here, hell will break loose. So it is very important that people and organizations start to think about how can I protect myself. And that does not always have to be with a Datadiode. Sometimes a firewall is good enough as well, but people do not think enough. And this is a perfect example of how you can protect. Well, Renee mentioned already the solar systems and the Chinese threat in this case, and that goes further. But the industry is different than military and government, because the industry is also pragmatic. When we sat down with them, they said, yeah, one way nice, but do you really think that we are going to send an engineer at sea to do a firmware upgrade? That won't happen. We need a bi-directional solution. Yeah, and then government will never allow this. Military will run away. But they say, we want to protect ourselves. We agree on that, but it must be workable. And then we sat down with their CISO and we said, okay, you can do bi-directional, but you need to make sure that these two networks will never be connected, because then you've got a loop and a hacker has an option to get in. And he said, no, I will make sure that this happens in one room, physical room only. And once the upgrade is done, I'll switch it off physically, no power. And via that approach, you see suddenly that the industry is becoming secure aware, and they're willing to take steps. And then there are options. The same applies here. They were used that there was a web server and that an operator could very easily select certain options. But yeah, with the Datadiodes, that's difficult. So we run a web server here, sends it across, and these two networks are separated. So there are options, and you need to think about what you want. A lot of customers have LDAP. And yeah, LDAP replication is possible over a Datadiodes. You make a dump of the LDAP server, transfer it, and import it. And then suddenly it's available in the red network. With LDAP, that is possible. With Microsoft Active Directory, it is not possible to run over a Datadiodes. That protocol is really bi-directional. Syslog. We spoke about Splunk, but Syslog is there for many years, for decades. And Syslog normally runs on UDP, although you see a lot of customers moving to TCP as well. And yeah, so both UDP and TCP, you can send it across the Datadiodes to your centralized Syslog server. No problem. But the hacker will never get in because the Datadiode blocks it. I will skip this one. SNMP traps will go over a Datadiode so that you can send everything to your centralized network management. You can send even emails over a Datadiode. If I have Marck@black.com, I can send an email to mark@red.com as long as the protocol is SMTP. If this one from this server to this server is SMTP, it will work. Here I can use IMAP to this server. You cannot run IMAP from this server to this server simply because IMAP is bidirectional. NTP. It is very important that if you have two networks, two security domains, two different security domains, that they run the same time. And that's also possible over a DataDiode. So this server, NTP server, on the internet or somewhere else, will inform all the systems here. But it will also connect to the black proxy. So the black proxy gets its time from an NTP server, but it sends it across to the red proxy. So this red proxy will have exactly the same time as this one. Then you can install also an NTP software here. So this one becomes NTP server as well for the red network. So that all the systems across the two domains, security domains, have the same time. And yeah, DataDiodes become more and more important. So for certain customers, it is pretty key that it is always up. And we came up with an HA solution. That means if one of these components fail, it will take over. And you might think, well, big deal, simple. No, that's not simple because there is no return path here. So you need to take extra steps. And one of them is active, one of them is passive. The active one has the virtual IP address, so all the information will go to the active one. If the one on top is active, sends it across. But this one will send it also to the passive one, who will also send it across. Here you get the same information and you can decide if one is passive, it will delete the information or it will do something with it and it's up to the application. If now this proxy dies, this one will take over automatically and still send the information across. Since this one can send its status, this one knows it's active as well and will become active. But if these two work and a DataDiode dies, or one of the proxies here, yeah, this one will never know. So if this one is active and then suddenly this one dies, they will not know. But since they both receive the information, everything continues to work. That's with HA. And then you get more and more questions from customers once you start with a DataDiode. They said, how can I get my Microsoft updates to the other side? Well, we have a Oasis replicator for that, which runs on the Oasis server. And the Oasis repository with the database is replicated across to the other side, so that all the Microsoft systems in the red network get the same information and the same security patches. If you do it for Microsoft, you need to do it for Linux and GitHub as well. So we have an rsync replicator, which can synchronize an entire repository to the other side. And you can do the same with antiviruses. So you have an antivirus server, it sends its update files, you send it across, import it in, and here all the clients get the updates. Then I'm almost there. A few miscellaneous cases. It is possible to have multiple proxies with multiple DataDiodes all terminating on one. So let's say I have security domain 1, 2, 3, 4, and they're low. And here is the high security. They can all send the information across the DataDiodes and terminate on one. That saves you 3 proxies. We have especially military customers who want to see a DMZ. So the owner of the red network is willing to accept this DataDiode, this link, and if this is DMZ, it's willing to accept it. It's a little bit overdone, but this is how certain organizations work, and that is possible with the DataDiode. Secret services are using this. You create a huge Hadoop cluster, you gather all kinds of unstructured information, and then via AI, machine learning, you start to make connections. You don't want that information to go out, so you protect it by a DataDiode. Key management systems or certificate servers. Yes, you should never allow a hacker to get access, but you want to share your certificates and your keys. So you can send those out into the field to the clients, but the hacker will never be able to get in. Telcos, by law, they are forced to provide the information to police or intelligence services if there are criminal activities. But these telcos, they don't want intelligence or police in their network, so defend themselves by a data diet. And last but not least, this is an old one, but still used within many military organizations. The people, they work, they go into a bunker early in the morning, they come out at night, and they have no clue what has happened. So they asked us, can you send RSS feeds over a data diet? And these days, everybody's using video now, but it is still possible to send RSS feeds. So that was my last example of how customers over the past 25 years started to use data diets. If you have any question, please let me know.
Thanks again. If anybody is interested in, or I've switched to Estonian, kui keegi on huvitatud, et olge head, andke märku ja loodetavasti oli sellest kasu ja nendest lahendustest on, ma usun, kindlasti ka teile kasu. Aitäh teile ja head päeva. Thanks guys and let's keep in touch. And if we have any questions, then we will definitely reach you. Okay.
Bye. Thank you very much.
Bye-bye.
Bye-bye.
Bye.